Lesson 1-5, Multiply Matrices, which is the same as 12.2 out of your textbook, and the rest of the slides will say 12.2 in this video. So yesterday we learned about matrices and how to add and subtract them. But how would you add and divide? Well, today multiply and divide. Today we're doing the multiplying, and we'll later learn you can't divide by a matrix. Matrix multiplication can only happen if the number of columns of the first matrix is the same as the number of rows of the second matrix. Because of that, order does matter. It has to be lined up. So the columns of the first equals the rows of the second. We can multiply a 3 by 5, because remember this is rows by columns and rows by columns. The columns of the first has to equal the rows of the second. So if you write the dimensions in order, the middle two numbers have to be the same. The outer two numbers will give you the dimensions of the result. But notice, if I were to switch these around, so it was a 5 by 2 times the 3 by 5, the middle numbers aren't the same anymore, and you can't even multiply them. Order does matter. The first matrix has to come first when you're multiplying matrices. So here's how you multiply. You pick a row in the first matrix and a column in the second matrix. I suppose first of all we should double check, make sure we can multiply these. So we have a 2 by 2 matrix and a 2 by 2 matrix. Middles are the same, and the dimensions will be a 2 by 2. So I pick a row in the first matrix and a column in the second matrix. It's always row and column. And I multiply the first. So I'll multiply the 1 and the negative 2. And then I put a plus, and I multiply the second thing in the row and column, 2 times 4. That was first row, first column, so it went in the first row, first column of the answer. Then pick a different row and column, maybe first row, second column. And multiply the first, so we'll have 1 times 1 plus, and you move over, 2 times 3. And that was first row, second column, so the answer went in the first row, second column. Then pick a different row and column. So maybe I can go second row, first column. I'll multiply the first, so I'll have 0 times negative 2 plus, then multiply the second, it's negative 3 times 4. And then we could do second row, second column, multiply the first, 0 times 1 plus, and then you move along, negative 3 times 3. And now we have multiplied each row of the first column, of the first matrix, with each column in the second matrix. So each row in the first matrix times each column in the second matrix, and you get all your answers. So now you just have to simplify those. So if we take this first one here, it looks like it's negative 2 plus 8 is 6. Then 1 plus 6 would be 7. 0 and negative 12. 0 and negative 9. And there's your answer. Let's try another one. Can we multiply these? Well, this first one is 2 rows by 3 columns. The second one is 3 rows by 1 column. The middle is the same, so it is multipliable. And our dimensions will be 2 by 1. So 2 rows, 1 column for our answer. Process is the same. Pick a row and a column. Multiply the first, so we'll have 1 times negative 1 plus the next 0 times 3 plus the next is 4 times 5. So you multiply, plus multiply. You always go across and down. So that was first row, first column. There's no other columns. Let's go with second row, first column. Multiply the first, -2 times -1, plus 3 times 3, plus 2 times 5. And that was second row, first column. Then if we take care of this first one, looks like we have -1 plus 0 plus 20 would be 19. And the second one would be 2 plus 9 is 11 plus 10 is 21. All right, let's try another one. Let's use these matrices to evaluate 2 times A times C plus B. So let's write it out. We have A times C plus B. Order of operation says we have to start in the parentheses, so let's multiply these matrices. Can we? Sure. It's a 2 by 2 with a 2 by 1. The middles are the same, and our result will be a 2 by 1. So let's multiply the first row, first column. So I'll have 5 times 2 plus -9 times -6. And then we can go second row, first column, -1 times 2, and 3 times -6. Let's simplify. 10 and 54 is 64. -2 and -18 is -20. All right, next order of operations says we multiply, so we'll have the 2 times the 64 and the 2 times -20. And then we can add 28 plus 0 is 128. -40 plus 4 is -36. And there you go. That's your answer. The members of 2 bowling leagues submit meal choices for an upcoming banquet as shown. Each pizza meal is $16, each spaghetti meal is $22, and each Sam's chicken meal is $18. Use matrix multiplication to find the total cost of the meals for each league. Well, let's write a matrix for what was ordered. So we have pizza, spaghetti, and Sam's chicken. All right, and we're going to multiply that with the prices. But I would like the pizza to be multiplied with the price of a pizza, the spaghetti with the price of the spaghetti, and the chicken with the price of the chicken. So, and I want them added together. So if I multiply them like this, because remember, we'll multiply going across and down. All right, so our first row, first column, will be 18 times 16 plus 35 times 22 plus 7 times 18. And then we can do the second row with the first column. We have 6 times 16, 40 times 22, and 9 times 18. So then we just simplify that. Get 1184 and 1138, which means the top one is League A, and they are going to have to pay $1,184. League B is going to have to pay $1,138.